everybody. Thanks for joining us. So we're going to be talking about installer packages today. So we're going to be covering what they are, how adversaries abuse them across all the operating systems, and why adversaries are choosing installer packages to abuse over other file formats. So I'm pretty excited to get in the weeds, and we've got Kat Self and Frank Lee. We're here to collectively geek out about this. So let's dive right in. So quick intros. I'm Matt Graber. I'm the Director of Threat Research at Canary. I've been here at the company for over 4 years now. I've got a background in offense, defense, malware, reverse engineering. I was active military for a while. And yeah, I really enjoy leading our team, diving into topics like this. Kat?
Got to start it off with the mute button. My name is Kat Self. I work on MITRE ATT&CK. I'm one of the maintainers and the lead for everything macOS and Linux. Previously, I was a red teamer. And then previous to that, I was in military intelligence. And so now I just kind of blend all three together.
Hey everyone, my name is Frank. In a past life, I did digital forensics and incident response. Now I'm currently a threat hunter.
All right, so what do we have lined up? Again, we're going to talk about what installer packages actually are. This is one of the things that we always have to consider, like how do we scope what we're researching, what we're detecting, what we're talking about. Installer packages is a pretty broad topic, so we'll narrow in on exactly what it is we're going to scope this presentation to in just a minute. Again, we're going to talk about installer packages, what they are and how they're abused across all of the operating systems. And then finally, we'll wrap things up and Kat's going to talk a little bit about what is new in attack. All right, so why do we care about this? Well, we care about it because attackers have been abusing installer packages for some time. On the Windows side, we're going to be focusing on msix installer packages. That's not the only native installer package format, but it's definitely been a recent trend that we've been seeing where it's been abused. So we wanted to take the opportunity to get in the weeds a little bit and discuss how you would be able to analyze the file format, what it looks like, and how to do some intelligence analysis to identify variants. And also, Frank's going to be getting into some of the threat intel as to like how attackers are actually abusing these. But regardless of the operating system, adversaries care about installer packages because, like many other file formats, they offer the opportunity to execute malicious code. They can also be designed to look legitimate while easily blending their malicious code into what otherwise looks and feels legitimate. All right, so what are installer packages from the MITRE ATT&CK side of the house?
All right, so first and foremost, if you've noticed, everything looks like a box. I love the fact that that is the one theme every operating system has at least agreed upon, is that they put packages in a package. I just thought that was kind of funny when I was looking at all the different variants. So just to kind of level set really quick and build on what Matt was talking about, let's say, and I'm going to use an analogy for this because I love my analogies, but let's say you're going to go move somewhere, right? Well, before you even move into an apartment, you're probably going to check just to make sure it's clean. Like there's many times that we've all gone into it and we're like, this needs to be fixed and this needs to be cleaned. And then you actually like load up your truck and then you move all of your stuff over and you put it into the house, right? And then lastly, you do a check. Did anything break? Like, do I actually have everything out of the truck? That's kind of what installer packages are, but for software. And so essentially like what we're going to do, or what these do when we break this into the MITRE ATT&CK framework, this is actually a sub-technique of a technique. So event triggered execution in MITRE ATT&CK specifically references like if A happens, then B is going to follow up and happen as a result. And in the case of installer packages, it's like I'm moving, so therefore I'm going to need these different components to be able to run and execute. And in our case, on Windows, on Linux, and on macOS, each one has their own type of installer, because at the end of the day, we have a problem that we need to solve, which is deploying software. And for this sub-technique, we'll specifically go over how these packets are structured, and then how these are abused by adversaries.
All right, well, let's dive right in and start talking about Windows. All right, so as I mentioned, there's two primary native installer package formats. There's MSI, which has been around forever in Windows. This has been talked about extensively. It's a very old file format. For those of us who have ever dealt with analyzing MSIs or building them from scratch, it's structured as a database file. So you can actually create an MSI file on the fly with the required APIs by effectively crafting SQL queries. It can do a lot, and they can be signed. And yeah, again, adversaries abuse these a lot. But as I mentioned before, MSIX is sort of like an extension of MSI. Well, it was completely re-architected. It has none of the look and feel of the original architecture. An MSIX file is just a zip file containing some required files, which you can see the image on the right. We're going to be talking a little bit about the app manifest XML file and the appx.p7x file. These are both required, and they describe what is actually packaged in the MSIX. And in the case of app signature, it is the signature that's used to sign the entire package, which can help us out as Intel analysts to identify similarly signed samples. So the MSIX file format, by default, it has the following registered file extension. So MSIX, MSIX bundle, AppX, AppX bundle, and app installer. Adversaries are unlikely to use the AppX file extension. That's actually an older version of the MSIX file format, where everything is contained within like a sandbox container environment, whereas you don't have such a restriction in MSIX, and adversaries are not going to want to have any code execution restrictions. Hence, they'll most likely ship a malicious MSIX. An MSIX bundle file is what allows a developer to bundle the same software package, but for multiple different processor architectures. All right, so let's dig in and look at an actual malicious MSIX file installer. So this one was relevant to an incident that we were investigating recently, where we published a threat for one of our customers that was signed by this malicious code signing certificate. It was a different quote software product. This one just happened to have a different name, packaged a little bit differently, but was signed by the same signer. So the adversaries, they try to make these look as legitimate as possible. So whatever the Blender software is, I think it has to do with like 3D animation. An adversary could go, take the corresponding icons and then just package everything together. They'll often package a legitimate executable, but then what they'll do is they'll shim in some extra functionality, often case, which would be like a PowerShell script, which would execute first before transferring control over to the legitimate executable. All right, so the questions we have is in this case, what is Blender? Is it actually Blender? And if not, then what is it and what is it doing? So the image that you see on the right here, if you just double click any msix file, this is the same consistent prompt that you would see. And yeah, let's move on here. So if we're going to analyze this file, it's pretty straightforward. You first want to extract all the files embedded within it. So you can just rename it, rename the extension to zip, extract the files. And then I wrote a PowerShell script to ease the triage process. I'm going to show the output of that in just a second. But again, the two main files that as malware analysts we'd want to pay attention to is appxsignature.psmnx. This gives us the signer information for that package, and appxmanifest, which describes what executes first and which files are packaged with the msix, in addition to some other attributes that may or may not be relevant. All right. So I ran the PowerShell function get app package triage info on this file in question. And I just wanted to call out a few fields that if you get into the habit of analyzing these, there's some things you should definitely pay attention to. So first is the publisher. So this is the full subject name of the signer. This will help us out when we're investigating things like, say, in like virus total intelligence, if we're trying to find similar samples. It's also really relevant because the way msix works when it installs software packages is it installs it to a very consistent location on disk using the, it's called the package full name, which consists of the name of the app, in this case, blender.blender, combined with the version and the architecture, and then the publisher ID. The publisher ID is a hash of the publisher subject name. So this can actually come in handy too. This can be like a quick and dirty way to identify if an msix is actually signed by Microsoft or not, because Microsoft has two very well-defined publisher IDs. So anything that wasn't one of those publisher IDs could serve as an easy way to just come to the conclusion that it's not from Microsoft. Within appxmanifest.xml, there's some additional properties. For example, this was built in the using a Russian language pack, which is kind of interesting for us to know. And I mentioned that msix files can run in an unconstrained, like non-sandboxed environment. That's specified in the manifest as well, which we see where it says run full trust. And the cert thumbprint, we can take that value, and if we have access to something like virus total intelligence, that's a very easy way to search for similarly signed samples. Now, what is the actual the actual executable that will run first thing when after the msix is installed? So that's specified in the applications portion of the manifest. In this case, what will execute first is AI stub x86.exe. If you were to Google that, you would see that that corresponds to the advanced installer PSF launcher utility. So what is PSF? This is an extension, I guess you could call it, for the msix file format that allows you to shim in additional functionality for an installer, which sounds really enticing for an adversary if they want to take something that's otherwise legitimate and shim in their own malicious functionality that could execute before a legitimate installer executable. So in this case, PSF configuration points to this start script update PS1, and we'll look at that in just a moment, the contents of that PS1 file. And then finally, you get some additional metadata, which can come in handy if you're trying to identify similar samples from an adversary. All right, so I mentioned that certificate thumbprint value. We have access to virus total intelligence here at Canary, which is really nice, which means we can do a search like the following. So signature, colon, and then the thumbprint value. And I was able to very quickly identify these other MSIX files that were used with the same code signing certificate. So even without cracking open the MSIX and actually analyzing the code in it, I'm starting to get a sense that something is awry here. If this NGA Engineering Limited code signing cert was used to sign these products, like these are all independent products, all of which have their own respective software vendors, none of which correspond to anything related to NJA engineering or whatever. So it's definitely starting to look a little shady without even analyzing any code. All right. So again, I mentioned the code that was shimmed into this executable was this PowerShell script. And again, that's using the advanced installer PSF launcher, which is a repackaged version of Microsoft's open source code that allows you to extend the functionality of MSIX files. Okay, so looking at the actual contents of update.ps1, those of us who have looked at malicious PowerShell enough would be able to recognize this looks pretty shady. So IWR is an alias for invoke web request. So that's just going to download some web content. And so what is that content? We don't know exactly, but we do know that it's PowerShell code based on the context of the content of what is downloaded is passed to IEX, which is an alias for invoke expression. So you can just feed invoke expression, any arbitrary PowerShell, and it will execute that. So this is what we would refer to as sort of like your canonical PowerShell download cradle. All right, so when this is installed and actually executed, what does it actually look like in a process hierarchy? So I mentioned before that the first executable that executes as defined in the AppX manifest is AI stub x86.exe. And if you're able to see some of the small print on the bottom, you can see the process tree that executes, and you see AI stub x86 executing. And then child processes of that is, well, you see xcopy, but then you see PowerShell.exe. So that is the actual update.ps1 script being executed just prior to blender.exe running. Now, in this case, blender.exe is technically a legitimate executable. It's just not the Blender executable. It's just it's a Microsoft signed Visual C runtime library installer executable. Presumably the adversary just probably wanted to use the same legitimate installer that looked like it was installing something, but in the end didn't really install that much, when ultimately all the adversary wanted to do was to get their malicious PowerShell code to execute, which by the time you see this installer prompt, it's already too late. The malicious PowerShell code has already executed. All right, so Frank's going to take it from here and dive a little bit deeper into how MSIX files are being abused in the wild.
Thanks, Matt. Yeah, so let's dive straight in. One of the benefits that we have as Red Canary is that we are the managed MDR for so many different customers. So we get a wide view of kind of how these MSIX files are being abused across various different types of industries, across different sizes of customers, across different customers with different maturities. And so we started seeing a lot of these intrusions that were starting because of MSIX. And so we kind of had an interest in, let's kind of understand if there's any behavioral overlaps or if there's any infrastructure overlaps between some of these intrusions that we saw. So we kind of started looking at the various intrusions and putting them together, and noticed that they kind of fit neatly into 3 clusters of activity, which I'll talk a little bit more about. Also, if you wanted to find out more about our research, the results of our research, and you wanted to maybe find out detection analytics, we published a blog post about this earlier this year, so feel free to check that out. But essentially, the 3 clusters of activity that we observed, the first one was it started from msix, and then it dropped the update.ps1 that Matt was talking about. And that would actually load some Carbonac malware, and it would ultimately result in Net Support Manager. That's a remote access Trojan that got dropped as the final payload. It's really interesting that Microsoft also saw something very similar, and they attribute it to what they call Sangria Tempest. We at Red Canary would say that's Fin7 activity. The second cluster of activity starts off again with msix, but it's really interesting this time. Instead of dropping PowerShell, it drops an executable called install.exe. And in this case, it's based off of compiled Python code. And the final payload that is dropped is zloader or batloader. And the final cluster of activity that we saw, it starts off with msix. It once again goes to PowerShell, but the final payload that it drops sometimes varies. It's either we saw a REST client 2, we saw Redline, and we saw FakeBat. So let's kind of see how msix abuse has looked throughout the time. So the earliest activity that we saw with msix abuse started in July 2023. Cluster 1 activity we mainly saw around late November, early December 2023, but very strangely, just earlier this week, we saw another instance of Fin7 activity. So we think that there's a possible currently ongoing Fin7 campaign. We only saw 2 intrusions for cluster 2, and that was only in December 2023. So that might have just been an attempt by an adversary to pivot and change up their TTPs, but for whatever reason, they decided that they weren't going to continue with that. Cluster 3 is by far the most common type of msix intrusion that we observed. We saw between 1 to 5 detections every month since July 2023, except for February 2024. And the good thing, I guess, is that we're not the only MDR that's seeing this. So there's other MDRs and other people in the security community that are seeing very similar things. I've had informal conversations with some of my friends at like Mandiant MDR talking about this stuff. Rapid7 recently released a blog where they called some of the cluster, I believe it was cluster 3 intrusions. They said that they saw it, and they called some of the malware used in that IDAT loader, while Elastic Security published a blog a while ago, and they called that Ghost Pulse. So we as a community are seeing that this is a highly relevant threat, and it continues to be abused in the wild.
All right, so we've talked a lot about what adversaries are doing with msix. So now let's talk about what we can actually do about it to prevent malicious msix files from being executed. Fortunately, we've got a few things in our arsenal, both inbox and configurable. So one of my favorite mitigations you get for free, if an msix package was signed with a revoked certificate, so long as you are connected to the internet so that the revocation check can actually occur, it will not execute. Now, if you're executing it via the UI, which most unsuspecting victims would do, they're not going to get the prettiest output. They would just get this generic parsing error message. So I don't know. Hopefully they wouldn't go try to find, another version of some cracked software that they're trying to install. But regardless, this is really cool that it just won't execute at all if the certificate is revoked. And one cool thing that happened was, as we were building out these slides, That Blender MSIX, that malicious installer package, it would have executed, but as soon as I realized that it was malicious, I reported it to the code signing certificate authority, and they revoked it almost immediately. So, yeah, it's kind of like a game of whack-a-mole, but at least I'm doing my part here. Another option is to disable the installation of non-Microsoft Store apps. This could be a feasible setting within your enterprise if you're not in the habit of installing like third-party MSIX files like from disk that don't originate from the Microsoft Store. And the way that Windows can distinguish between a store signed app and a non-Microsoft Store signed app, it's all contained within the code signing certificate. There's just some very specific attributes within the certificate that would indicate that MSIX did originate from the Microsoft Store. So that's ultimately how Windows is able to enforce that. And fortunately, in this case, you would get a somewhat more descriptive error when the MSIX fails to install. Okay. The next option is you can set a GPO to prevent standard user installation. This might not be quite as feasible. For example, I can't quite recall, but I don't know if setting this would prevent a user from installing a Microsoft Store signed app. So this is something that you would have to test, but I just wanted to call this out for the sake of completeness. Okay. My slides are lagging a little bit here. Hey, Frank, could you try changing to the next slide for me?
Yeah, I'm trying on my end. Does that work?
Is it hanging for you, or which slide are you on?
I see the WDAC slide now.
Oh, okay. All right. Yeah, it's just hanging for me, but okay, I'll just speak to that. So, last but not least, the last mitigation is Windows Defender application control. So, if you're able to and can get to a place where you can set granular allow lists that specify like what is explicitly allowed, WDAC.
So Frank, do you think you can finish that slide?
Yeah, I think what Matt just meant to say was you can use WDAC to basically as a mitigation for MSIX, and you can use it to block certain types of MSIX if that's not intended to be run in your environment. All right, Kat, you want to grab macOS?
All right, so back on my favorite topic, macOS. For those of you that know me, know I have a preference. So first and foremost, out of all of these images that you guys see, and yes, I will absolutely ask questions and expect you guys to actually answer in the chat, just FYI, so be prepared. Out of all of these, which do you all think is actually an executable? Give you like 2 seconds. I'll continue on, but okay, delayed typing. The way macOS works is like Steve Jobs had a saying a long time ago. He was like, my goal is for a 6-year-old to be able to use this. And thank you for answering. You're awesome, Matt. But his goal was like, he wants it to be very simple, very seamless, right? So hence the installers. And these are all of the different installers. Now, fun fact, only one of these is actually an executable, and that's the very last one. The rest are actually file systems. The way that macOS works with their packages is that they want to be able to present this seamless interface. So as a result, these are all actually file systems that are kind of masquerading as if they are an executable. So what happens in the back end is Finder actually handles a lot of this stuff seamlessly and invisibly for you. So Finder is going to call like the disk installer. Finder is also going to call like the unarchiver app. And the macOS store is actually a .app file structure. So each one is actually totally different file structure in order to be able to give you this seamless experience. So we're going to break down these and then kind of go over them a little bit more because they're so different. So we'll start with the sketchiest one first, because obviously anytime you have to open up your command line, it feels like malware if you're not used to that. So usually when you download things from GitHub, that's when you're actually going to be using like the terminal, right? Because you're at that point, you're at a different kind of user level. You're not the 6-year-old trying to make their app work. You're at I'm probably a developer with developer tools installed, and it's just a different game. And so we're not going to take too much time, but there is a blog that this is a very common theme that Patrick Wardle actually published out. And it's where someone took a redirect and then they actually redirected people from, instead of brew.sh, they made it homebrew.sh and then had them download a malicious package. So, which then prompted a Flash player, which then starts this process over again. Since they didn't specifically use pre and post install scripts, we're going to ignore that. But I did want that reference there because it is something that is not too far, like not too long ago. Now, focusing on the DMGs. So this is actually a file format. So I'm going to walk through kind of like what this looks like. So on the user side, right, you open up your website. Like let's say we're going to go to Slack, and then you download your DMG file. What's really ironic is that DMG is kind of like the current standards. This is probably what you're going to get for most things, even packages. Like you're going to get it wrapped inside of a DMG. And so you're going to download DMG and you're going to double click that, right? And then you have another window that opens. But what's really happening on the back end is the disk image mounter, which is like an Apple system utility. It's like actually like Finder calls disk image mounter, which then opens this up. And it actually, like on the back end, essentially the command line equivalent for this is like HDI util space attach. And then that's essentially going to be mounting this to your system for you to be able to read this file. And then it shows you this app. So that applications folder, this is where everything in macOS, like this is where all of your apps are expected to be housed, essentially. So it actually provides you a shortcut link there. And then it provides you this .app structure, which is what macOS views as an application. With this .app structure, when you actually open it up, like so if you right-click show package contents, you're going to see this very bottom right window. Now, in this bottom right window, there's 3 things that you have to have. And this is actually very telling for how your app is structured. You have to have an info.plist. When you move this to the applications folder, it actually registers this info.plist with the system. So when you do like command spacebar and you want to be able to index and search your system for this application, this is registered using this. So that's how it's going to be in your Spotlight plist file for you to be able to index that. It indexes it, yeah, words are hard. It gives you that list of indexed items that you can actually search your computer and system for. So info.plist is one of them. Another one is resources. And another one is macOS. Now, macOS is going to have to be where macOS expects your executable to actually be. So that's where you're going to grab the binary from. But the resources, this is where you're going to find all of your scripts. This is going to be your icons, like if you're going to run, like make sure you run the script prior to make sure they're running with a license. Or if you want to run the script after it closes the application to make sure it kills this other process, that's where you're going to put those scripts. So we're not going to cover that because there are actually examples out there, but this structure kind of bleeds into other MITRE ATT&CK techniques. So moving on. If you do want to do a deeper dive, Howard Oakley is probably one of the best bloggers that actually reference all of macOS's like native utilities. He'll actually reverse them and then provide a really, really good context from everything from logs to like understanding the process flow of how these utilities actually work together. So our focus for today will be understanding the actual package, right? This is kind of getting bled out or this is getting more in favor is the application style with the DMG, but this is actually still valid and still around. And so the way installer scripts or packages work is it's actually 3 parts. So you have a kind of like what we were talking about earlier, right? With like, you're going to move, you have to like go in, make sure it's clean, and then you actually move and unpack your stuff. And then you're going to like do your cleanup and make sure nothing's broken. It's kind of broken into those same things. You have your pre-installed scripts, then you actually unload your content, which is where it's like writing files. And then you have your post-install scripts. A thing to note about this is in attack, we have this labeled as not only persistence, but also privilege escalation. So when an application is installing on your computer and it pops that window like, hey, we need permission. Well, just so you know, that permission is actually inherited by the entire installer. So every script that you're now running is now going to be run with those permission levels. So if you want to install launch daemons like Apple Juice does, then you're actually going to be able to do that if you have local admin rights on your macOS host. And if we're being honest, we all know you have local admin rights on your Mac host, even if you're in an enterprise network. So it's just a thing. But yeah, that's essentially the structure of this. The reason why this is relevant is because in the case of Apple Juice, which Frank will actually be going over deeper next, it actually only does 2 parts of this, right? It takes a legitimate binary, and then it unpacks that. But then at the end, it also does a post-install script. I don't know if I mentioned this earlier, but for you guys to have like a reference if you work on macOS a lot, you know, when the window pops up and you're like, would you like to move this to the trash? Like that's probably a post-install script because it wants to clean up after itself, right? So they're not always bad on macOS. They're actually quite convenient. And so on Patrick Wardle's blog, who actually does a really, really great job of breaking down this analysis, he uses this application called Suspicious Package, which sounds suspicious, but it's actually to look at suspicious packages. But this is actually like a really great tool that if you're curious about this and you want to be able to read these file systems easily with a GUI, it'll actually like break out these different components. So that way you can actually like look at this script and understand it versus having to dig through and play with the different system utilities that are native in macOS on the command line. So I will hand it over to Frank.
Yeah. Thank you. So let's talk about in the wild exploitation of installer packages on macOS. So traditionally, we really only see in terms of adware, and there's really, really limited number of times when they're actually using malware. But one of the more targeted or the more famous times that there was malicious package abuse on macOS was in 2018. So the Lazarus Group, which is attributed to North Korea, created a legitimately looking or a seemingly legitimate cryptocurrency company to host and distribute malware that was masquerading as cryptocurrency trading software. It was about a 3-year campaign, and it targeted companies in various industries across primarily Western countries, but it also hit Russia as well. And the final payload in those intrusions, or in some of those intrusions, was a remote access Trojan that was named Fall Chill. But let's look a little deeper into what the program flow of Apple Juice looks like, and maybe how we might be able to use that to create some methodologies to hunt for that activity. So here's the program flow. And I think the way that I color coded this might seem a little confusing at the beginning, but I'll kind of explain it through. The colors talk about the first 3 campaigns that Apple Juice was used. So in the first campaign, that's the things that are in the black. So it installed so the first campaign was actually, you can substitute Union Crypto Trader with whatever the name of the campaign was. The first one was actually called Sealess Trade Pro, but it installed that into the applications folder. And then it essentially just executed a post install script that would move the plist to the launch daemons so that it would execute every time the system booted up and then essentially just execute it. The second campaign was called Crash Reporter. And so this time they made the post install script a little more complicated. They changed the file permission of the plist to root, and then they moved it to a folder, to the library folder, and then they made it executable before they ran it. And then the third campaign was Union Crypto Trader. So this, they made it even more sneaky by putting a period before the file name in the applications. But as noted in the blue note, the leading period makes it unlisted in the Finder app or default terminal directory listing. So if maybe a user is just scrolling through it, they might not actually identify that there is the malware installed, and that allows the adversaries to be a little trickier and hide better in on the victim hosts. So what can we take away from that program flow in terms of maybe creating some hunt methodologies? The first is that if your organization doesn't explicitly approve the use of cryptocurrency tools, it's probably a really, really good sign that there's probably something going on if you see some kind of cryptocurrency application in your environment. Even if it isn't Apple Juice, and it probably, to be honest, most likely won't be Apple Juice because the last kind of campaigns for Apple Juice ended in 2021. But if those cryptocurrency software was able to make it into your environment somehow, there's probably something there worth digging into. Maybe there's some other type of malware that's dropping crypto applications there. Second, you might be able to go through your launch daemons and try to see, is there anything kind of that you don't know, or is there anything cryptocurrency related? So in all 6 of the campaigns of Apple Juice, all the daemons that they created all had cryptocurrency names. So if the victims there had gone through, done some threat hunting and looked at the daemons and had identified that there was maybe cryptocurrency related daemons there, and those victims didn't have any need to have cryptocurrency applications on those endpoints, probably they could have caught the issue a little while sooner. Third is looking for ad hoc signed applications. So the picture on the right is from the Objective-C blog that Kat referenced, but essentially ad hoc signed applications are very similar to self-signed applications on Windows. They're really just created as a way for developers to be able to create implicit trust for apps that they're maybe using locally. There really, really shouldn't be any unknown ad hoc signed applications on any macOS endpoints. So if there are, probably worth digging into. And lastly, if there are any hidden plists within launch daemons or the launch agents directory, the difference there is launch daemons executes on system boot versus launch agents executes when the user logs into a graphical session. But if there are any hidden plists in those directories with references or pointing to hidden or temporary executables or folders, again, that's probably something that you would want to look into, since those things should be pretty well known to your system administrators, and they should be pointing to things that should be persisting. So if they're hidden or if they're temporary, that might be an adversary trying to cover their tracks. Kat, back to you.
So onto Linux. So for some of you, probably one of my favorite quotes that I'm absolutely stealing from Craig Howland is Linux isn't an operating system, it's a series of commands, which sounds wonky, and every kernel developer is probably angry right now, but it's also very true. So that's actually why this technique is so relevant for Linux systems. I love Linux because it's free. But with that also comes some other aspects. And so what we're looking at right here is actually 2 different type of package managers. Now, the thing to realize about Linux is, well, Linux really, kind of to put this in a common tongue, that's such a D&D term, to put this in a very plain speak kind of way, Debian systems and NPM all of them use shell scripts. Every, like, I would say because of the case of outliers, most of them use shell scripts. And when you have OS distributions that are made of thousands of packages that are distributed via third-party sites, this becomes a very relevant technique for Linux systems, as you're going to see, as the way it's been leveraged in the wild. So on your left-hand side, we have Debian, which is a Linux distribution. The way that we commonly reference this is going to be like sudo apt get update or sudo apt get install something. The current version of this is actually sudo apt, but I don't know about you guys, but I grew up in the 1990s where we still use the commands from back in the day because they technically work. On the right side is npm. Now, every time you work in anything in the web, right, this is where you're actually going to be dealing with different types of package managers that actually manage JavaScript, because even this web browser that you're using right now is primarily built off of JavaScript libraries. So this actually allows us, these different package managers actually allow us to reuse code. So it's a good thing. It's not a bad thing. So I throw that out there because sometimes we're like, no, it's attached to a MITRE technique. We shouldn't use it at all. It's like, no. That's not the way this works. Like, attackers are leveraging this because it's genuinely useful software. So these are different types of package managers. One's for an operating system. One is for like code libraries. So the reason why this gets complicated is because in our ecosystem in Linux, this is what we have to deal with. And so when you're a developer, you have a different stack, right? When you're a server, you have a different stack. Just the operating system, its own stack. So all of these have to be compatible with each other. So once you start really like building out systems, right? These enterprises are actually facing a really tough challenge of making everything just work. So I don't know about you guys, but when I was a software developer for a brief spell, yes, dare I say, I was doing a lot of front-end work, and like all I cared about was making the picture render. Like, I didn't really care. I needed to be compatible for all of these different browsers, for all of these different devices. And like, this is where these package managers just shine. But with that said, so do the malware authors. So one example of actually basing this off of an operating system is something that actually SecureList found, which is awesome. This specifically uses, they kind of like break out this entire chain, right? Where you download something. Essentially, people are going to a legitimate website, which was like freedownloadmanager.org. And what's cool is SecureList actually was watching YouTube videos, trying to see when this was redirected. And so they noticed that sometimes users would be redirected that were giving tutorials on this, and sometimes they wouldn't be, which does actually lend itself to telling you that these domains probably fingerprinted, so they were going after a certain type of user or a certain type of browser, which is really common. And so, but they noticed that these users would go there. When they would click on the link for Linux, they'd download the Linux version. And for some of them, they would be redirected to a malicious site that provided an infected version of the free download manager. Now, just as everyone else has kind of shared, a lot of times the legitimate binary is in there. So we want the user to keep using this software, right? We don't want them to like be thinking that there's something malicious happening on the computer. So what they actually did with this one was they used the post-inst, or however you want to call it, because they're all acronyms in a way. And so thank you, Latin, for pre and post, right? So post indicates that it's actually going to be run afterwards. And in this case, what they did was they added a script with some notes about how they've been, dare I say, updating their malware. They had some activist comments. They have some Russian and Ukrainian in there, which all it really does is test if a file exists based off of an environment variable. But they leverage this to be able to help them with all of the rest of the infection, which then installed a cron job, which then ran a backdoor. So this is essentially the infection chain, but it's one way that they use the post-install scripts. Now, the way that this actually like happens in the infection chain, like for the way the installer handles this, and this is for everything. So this is actually taken like from one of the Debian web pages where they've actually broken out a flowchart, and the pre-install scripts are run. And if this works, then it will continue on, unpack the files, and then run the post, kind of just like macOS does, right? If you remember that installer where we had the pre, the unpacking, and the post, I think one blog said it was where they try to take a Unix-like system and make it look like Windows to make people more happy. But this does that same flow where you're running these pre-installed scripts, you're unpacking if that's successful, and then you're running your post-install. And there's a lot of configurations, right? Like servers use this. When you're setting up databases, you use this. You run post-installs afterwards to set your configurations. It's a very common day practice. But this is where that happens in that specific flow. So now on to NPM. So NPM is a JavaScript package manager, right? So in your front end, you have HTML, CSS, and JavaScript. And then underneath JavaScript, you have a ton of more different repositories. The reason why this is relevant is because there's thousands upon thousands of nodes in NPM, and there's no way they can see everything. They do a really good job, though, I will say that, because everything that we're about to go over was actually revoked fairly quickly. Like, I think the longest one that was up was like a month, and it did get like 1 million hits. But again, it's pretty impressive for having so many nodes that you're in charge of reviewing and being able to like capture that and pull it down. In this case, in this instance, what an adversary did was they used a pre-install script. So before your installer even worked, kind of like if you reference back when Matt was talking about the installer, like when you see the installer pop up, like it's already done, like you're already infected. When you're using the pre-installs, you're already infected by the time you actually see something else happen. In this case, what it's doing, it's running itself in the background. It's going to then be like, hey, Python, I want you to run this as a command with -c parameter. And then you're say, I want to download this, and then I want to run it. And then I want to background that process. So that's essentially what they're doing. But what's relevant here is that they iterated like 5 times on this pre-install script. Like the first one was actually like a who am I and like more of a fingerprinting. And then they started downloading, and then they started downloading and executing. So they iterate. So usually what happens is adversaries find something that works, they get it in, and they're like, cool, now we iterate, just like Agile. So, which brings us to, and which is perfect timing because now we'll have questions. What is new in Attack? So we just dropped Attack version 15. So if you guys have any questions on anything that we went over, please, 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 please put them in the chat, because this is a great time when you actually have experts on the call, and we're here to answer questions. And so don't worry about if they're stupid or if you're like, oh, I have to know more about this before I put it in. Just drop it in there. Like, don't worry about this stuff, because I can probably guarantee you have asked that question before, and probably in much more of an embarrassing format. So, but in Attack 15, which we just dropped yesterday, we go over a lot of the different items that we've covered. Like on the right-hand side, you'll see a lot of the new techniques that we have. We really try to like be very intentional when we're adding new techniques, because so many people are mapped to it. But my personal favorite one that we just added, of course, it's macOS, is TCC manipulation. So this is one that we've been working on for a while, but Marina Liang put in a blog that did an excellent job, where she actually outlines a ton of malware samples that she found that actually leveraged this. So we were able to write up a technique based on usage in the wild, right? Because that's the thing about Attack. One kind of thing like that I'll say is everything that we've gone over, the installer packages, everything that's in Attack, it's been seen in the wild. So that kind of helps you know how to prioritize some of these detections, because it's actually being leveraged. And so we were finally able to put this one in because we were actually able to verify that it's been leveraged in the wild, ironically enough, by DPRK. So that's kind of where we're at. Now we can open it up for questions. Okay, is it possible to detect pre-inst, post-inst files being backdoored and categorized into detections? Honestly, I'm going to tell you this right now. We're working in an enterprise environment and working alongside of a lot of detection engineers. It is possible. However, huge caveat on that, right? Like, I think everything depends on your baseline. So, and you don't know what's in there. I mean, it's probably not going to be granular, to be honest. Like at an enterprise that I used to work at, we had hunting rules, and then we had like legitimate rules. And the hunting ones, we would kind of prioritize as these are things that we need to look into. But the legitimate ones were like, yep, we're alerting, and there are actions that need to be taken. So you can, but it's going to be very, very noisy. So you're going to have to really, really know your environment. But yeah. And then Matt can probably even speak better to this.
I had to drop off quickly. Apologies. What was the question, Kat?
Oh, is it possible to detect basically the pre-inst and post-inst files being backdoored or categorize them into detection?
Personally, I don't know enough about that. Frank, maybe you've got some ideas. I could probably offer some advice on the Windows side of things.
Nothing too much off the top of my head. I mean, I'm deferring to Kat here as the Linux and macOS expert.
I would say use Audit, but definitely baseline your environment. And as far as the backdoors, like I don't think any single data point in detection is like a gimme, right? Like this is backdoored. Like no, like I'm not gonna lie. There's some really weird applications that do some really weird malware stuff, like Adobe, so and IntelliJ. So like all of those do some horrible things. So, I mean, I take that back. They do some not best practices. I think that's the euphemism we will use. But I don't think there's like a give me for any of those. I would probably say that's going to be a bit of process tree. That's going to be a bit of where something executing from. But with the amount that these are actually executing on Linux, and since so many distributions are made up of, like an entire operating system is made up of these packages, it's going to be one of those where your whitelist is a bit extensive and it might be kind of not worth the effort, right? I think a lot of times in security, it's like effort and care versus like time. And so I think it's going to be a call. So sorry, I can't be like, oh, and here's a solution for it. Like it's complicated. There's a reason why Linux is such a prone system to this technique.
Yeah, it's the same thing in Windows, honestly. Like there isn't going to be a silver bullet for separating the malicious MSIX and MSI files from all of the legitimate ones, for the same reason that, Kat, you said. Like there are legitimate installers that do really bad things that they shouldn't do, but also just by the nature of these things being installers, they tend to have a large footprint and they do lots of things and put files in lots of areas in an ambiguous fashion. So ultimately, from a detection perspective, we really do need to fall back to a behavioral approach, right? So like the MSIX that I called out, there may very well be plenty of legitimate MSIX files that shim in legitimate PowerShell scripts to do some like pre or post setup steps. But I mean, there's also plenty of malicious use cases as well. So yeah, it's really going to be like a case by case basis. And again, just we really need to focus on detecting malicious behaviors versus trying to identify a silver bullet that just doesn't exist for generically detecting malicious installer packages.
I'm seeing a question in the chat about how Red Canary detects some of the installer package abuse questions. It's kind of hopping on that really quickly. A lot of it is correlating like our internal detectors with kind of the EDR stuff and trying to look for some of the behavioral stuff that we called out. So, maybe sometimes like once we've identified that there's maybe a certain cluster of activity, or like MSIX will drop, like a malicious MSIX will drop this family of malware at the end, we might not have specific detectors for like the initial part of it, but maybe depending on the specific PowerShell script, we might have some detectors for that. And then when it starts to drop the other malware families, we might be able to detect on those, like maybe it'll detect on fake bat, or it'll detect on like that net support manager was dropped. And then from there, that's when threat hunting and our detection engineers go back and retroactively understand where this came from. And in those cases, we could see that it came from an MSIX.
Yeah, and that's a good point, Frank. Like in this case, like, well, in most cases, when it comes to detection, we don't really care about the suspicious or malicious behavior originating from MSIX. Like that's relevant for any threats that we're going to publish, but a suspicious or a malicious behavior is just that. You saw like update.ps1, right? Like that was a clearly suspicious PowerShell download cradle. And it executes in the context of PowerShell.exe, for which we have many detectors just for that particular behavior. So when an analyst is looking at one of those suspicious events, they're going to see the process tree and see that the parent and the grandparent process originates from an MSIX file. That will be a relevant detail to ship in a published threat. But again, like we didn't care about that fact in the first place because we're focusing on malicious behaviors because we can't anticipate every possible permutation of maliciousness that could be incorporated into an arbitrary file format, right? So again, this is why we have to be focused on specific behavioral indicators, but also, as Frank mentioned, specific threat-specific behaviors based on clusters of activity that we're seeing. So it's a good question, but unfortunately, that's all we have time for. Just want to thank everyone here for spending your time listening to us geek out about installer packages. We hope that you can walk away with either some new detection ideas, malware analysis strategies, intel analysis strategies. And other than that, yeah, thanks again.